Hi everybody, we're back with another tech video. This time we're going to cover 2.5-ton inner Cs and more specifically the kingpins and some of the failures we've seen with them and how to possibly prevent them from failing in the first place. As you can see, this is just a inner knuckle that's been cut off at the tube. Both the upper and the lower kingpin are here. These are welded in like this from the factory. They're welded on the outside, and they also have kind of a rosette weld on the inside. The way that they're designed is your knuckle here, it slides over top of the pins like that, and there's a bushing here, this, and it fits inside the knuckle here. It drops in, and then it rides on this pin here and just pivots on that brass bushing, and it's all greased and everything. So what I've done to kind of show how these pins have been failing is I machined this. It's not an exact replica, but it's a good representation of how these pins are set up. And what it is they all have this little lip here. It's just, 1/8 inch thick, and that's what's welded to the cast part. I'm not 100% sure why they did that. I'm thinking it's because they didn't want to dump a bunch of heat into the pin itself and possibly lose the hard surfacing on it. So what they've done is they've welded to this thin little lip, and what we've been seeing happen is when these things fail is that part in here, right along the edge of the pin, is what's cracking and what's failing. And I believe I have a picture. I'll add it to this video so you can see what it is. It's just one I found on Facebook. And usually what happens is if it's left unchecked, that pin gets more play in it, it'll keep working itself out, and it'll either break the pin or it can tear out this chunk of cast and rip the knuckle right out, or rip a chunk of the knuckle right out. Obviously I'm showing the upper pin. This mostly happens on the lower pin. It'll tear out on the bottom. That's where most of your stress is from the axle lift or the tire lifting on the bottom kingpin. So you definitely want to keep an eye on that. If you've been jumping or using it in hard competition, definitely check that. Make sure your pins aren't loose and starting to come apart. If they are, definitely get them fixed up right away, or they can get significantly cause a lot more damage if you don't take care of them. So now what we're going to go into is some of the preventative maintenance to keep these things from failing in the first place. Okay, here's our knuckle on. As you can tell, this is a 2.5-ton left-hand knuckle. These are kingpin caps with our bushings in them. There is an upper and a lower, and the way to distinguish between the two is the height between the two. You can see the upper is a little bit taller than the lower. You can see there the height, and the reason behind that is the upper uses a shim that fits inside here and just rides on top of the kingpin. So we'll throw these together, and then obviously these caps go on top with the grease nipple. So we'll throw these together and we'll be right back. I've got these assembled. I just put 2 bolts in for a demonstration. Lower cap is on there as well. Everything pivots, now you can see. But the thing I wanted to mention is these kingpin bushings are, how I feel, pretty critical to keep in good condition. If you don't keep up the maintenance by greasing, or if they get wore out, which they do actually quite quickly in a competition atmosphere, or if you're jumping, or if you have a really heavy rig, that brass in there will pound out pretty quick. And the thing I wanted to show is if there is a bunch of slop in that bushing and your spindle is here with your tire hooked onto it and it's pushing up every time you jump, it's going to cause a lot of shock loading on this lower pin with things slopping around. So if you can imagine that with a full-size truck or a heavy engine on top of it, it's going to create a lot of stress on these welds and the pin and the cast knuckle itself. So always try and keep an eye on those, keep them well greased, and then also check them regularly. All you have to do to check them is just jack your vehicle off the ground. You can leave the tire on and everything, and then just give it a wiggle on the top of the tire, or even put a jack under it if you want, under the hub, and just see if you've got any play in these bushings. And if they are, they're not hard to change. They're actually pretty easy, unless if you have a bunch of, you know, if you got a boot guard or a kingpin support on there, you can drop that out, and all you have to do is just support the axle, support the wheel and tire and hub assembly, and you can, this is obviously the top, but you can just pull these 4 bolts out, pull the cap off, and you can sneak that bushing out of there and drop a new one in, as long as there's no weight on the knuckle itself, and change them without disassembling everything. So they're not hard to change, but definitely they will help save your kingpins if you keep them in good condition. All right, here's our last line of defense, you could call it. This is our 2.5 ton lower truss kit. As you can see, we've got everything in upside down. So this is the bottom side of the knuckle, bottom side of the axle tube. This is the structure that we've come up with. It's got a plate here, a big brace that bolts onto the bottom 4 bolts. Uses a heavy Allen head, 9/16 Allen head. And then basically these 2 pieces here, they weld on to your axle tube. They're actually designed to be used with a truss. So you have your truss running, these will weld on there. And then this piece, it's a chunk of 2-inch solid stock threaded for 7/8 heim here, and then welded onto 2 pieces back in this area. And once this bolts on, it supports your kingpin, but still allows it to pivot on the heim joint. And the main difference between this kit and a lot of the other kits on the market is that a lot of kits on the market, they'll use a heim joint on this end, on the axle tube end, and then also a heim joint up here, which is fine if the force is pulling in this direction. Like if you land perfectly flat off a jump, it'll work fine. But if you do a nosedive or anything like that, and the force is actually coming this direction or any other direction, they're not going to do much, because the rod, because of the heim joint back here on the tube, can pivot and flex back and forth this way without anything inhibiting it. So that's why we went solid on this side, is so that if you do nosedive and the load is coming from the front of your truck onto the kingpins in a nosedive application type setup, this will actually provide a lot of support with the heavy steel and the 7/8 heim. So it does provide a lot more support, and we have tested these things heavily over the last season. We were having kingpin failures on our truck. It's a 5.9 Cummins sitting on top of the front axle, and we were having the kingpins crack out at once in a while. And since we've gone to these, we've done a couple freestyle events, some hard competitions, lots of big air, and no failures since we put these on. So if you guys are interested in a set of these, if you guys are jumping and need a little extra support, you can find them on our website. Thanks.